Hi everyone, I am Sasi Kumar from BIT Sindri and this is day 48 of improving my communication skills, and today we are going to discuss about waste management in construction, in which we will go through all the points that make sense, like how much waste generated in constructions, how much uh, energy we can save to manage the constructions, and all those topics means all those points we are going to cover in this conversation. So let's start with some just one solid opening statement, like constructions and demolitions. Waste become has constructions and demolition waste has become a critical sustainability concern, contributing to around 30 to 35% of global solid waste management, and it's placing sustainable pressure on landfills. However, nearly 70% of the waste is recyclable through BIM-based planning, on-site waste segregation, adoption of modular constructions, and recycle aggregate technology. The industry can significantly reduce environmental impact and project cost. Waste management today is not only an environmental responsibility but also a core economic and operational efficiency strategy for modern construction firm. The primary source of construction's waste include design efficiency, improper storage of materials, excessive procurements beyond BOQ requirements, demolition activities, and rework due to poor workmanship. Common waste materials are concrete, bricks, metal, wood, glass, plastics, and packaging materials. From an in, from an engineering perspective, waste can be classified into three categories: insert waste, non-hazardous waste, hazardous waste. In if we talk about inert, if you talk about inert waste, if you talk about inert waste, such as concrete, brick, and aggregate. If we talk about non-hazardous waste such as wood, steel, and plastic. If we talk about hazardous waste, including paint, solvent, and adhesives. Each category requires separate handling, storage, and disposal method. The most effective approach being right at the design stage. Techniques such as BIM help in accurate quantity takeoff, preventing over ordering and reducing rework. Additionally, adopting modular and prefabricated constructions reduce on-site cutting and material wastage. Okay. During construction, on-site waste segregation is crucial. Color-coded bin for concrete, metal, wood, and soil prevent contaminations and improves recyclability. Just in time (JIT) material delivery and proper covered storage also minimize deterioration and breakage. For recycling technology such as on-site concrete crushers can convert demolitions concrete into recycled aggregate, which can be reused for road subbase or non-structural concrete. Similarly, a steel reinforcement can be recovered. Foam works system reused, foam foam work system reused, and fly ash or GGBS can replace a portion of cement to reduce emission impact. From a regularity standpoint, the C&D Constructions and Demolition Waste Management Rules 2016 in India mandate waste segregation, safe transportation and disposal at authorities, recycling facilities, rating frameworks like LEED, BREEAM, and GREE. Further, encourage materials reuse and resources efficiency. A notable example is the Delhi C&D waste recycling plant, which processes debris into paving blocks and recycle aggregate concretes, demonstrating how waste can be converted in valuable resource. In conclusion, efficient construction waste management is no longer optional. It's directly influences cost efficiency, environmental footprints, and cooperative sustainability performance. as future civil engineering. Adopting these practice reflected our commitment to responsible engineer and sustainable development. So okay, so this is the point, and as I was saying the chat GPT, to be honest, so if I am not using that, so this is what the points I will told in the GD parts. So first I will how to start. Let's see. Similar construction and demolition waste has become a critical sustainability concern, contributing around 30 to 35% of global solid waste and placing sustainable pressures on landfills. However, okay, this is the point we will talk first things. Then construction and demolition. Okay, built built environmental contributes 38% of global CO2. Wait. Mm, mm, mm. First, I will talk about what is waste management. Waste management is a systematic planning, handling the storage, transportation, recycling, and disposal of materials. Its waste management is generated during constructions, renovations, and demolitions. Construction, constructions and demolitions waste. Construction and demolition waste is 30 to 35% of global solid waste. Built environmental contributes 38% of CO2 emission all over the world. Waste management influence cost, environmental impact, and project quality. 70% of waste can be recycled. Waste management. What is the main source of construction waste? Design efficiency and frequent design changes. Improper materials storage, excessive procurement beyond BOQ, excessive materials, site demolitions, and clearance operation, site demolitions and clearance operation, rework due to poor workmanship and lack of supervision, tap of waste, inert waste, in which we inert waste, that is concrete, bricks, and mortar, non-hazardous waste, wood, metals, glass, and plastics. If you talk about hazardous, let's write down the words that I'm coming. Hazardous, hazardous waste like paint, solvent, and adhesive. If you talk about how to handle inert waste can be handled by crush and reuse and recycle aggregate. And non-hazardous waste segregate, reuse, and recycle like wood, metal, and glass. Hazardous waste, paint, solvent, adhesive. Control disposal via licensed facilities. What is the way to management all the waste? Design stage optimization. BIM to reduce design stage optimization. BIM to reduce errors and reworks. BIM means wait a second, sorry. BIM full form. Where is that? Okay, let's BIM to reduce errors and reworks. A standardized and modular construction to reduce of cuts. Management, materials management, just in time, delivered to avoid overstockings. Means in construction field we see that everyone store all the materials just before the construction years and years ago. That's also increase the waste management, increase the waste materials. So just in time, we will deliver all the materials on the time. Covered storage areas to protect from weathers and damage. On-site segregation, color-coded bins for concrete, steel, wood, plastics, and soils. Segregation prevent contaminations, resins, raises recycling efficiency. If we divided all the uh, if we if we placed color coded bins in the site so that we can segregate concrete, steel, wood, plastic on the times, and it's increase the real time recycling and reuse technology. On-site concrete crushing, recycle aggregate for sub-base means if the concretes are in waste materials that we can crush on the sites and send to the roadside where highway is making and some things there we can use concrete as concrete and aggregate as a sub-base. Reuse of a steel reinforcement and homework systems. Use fly ash, GGBS, and recycled steel to lower carbon footprint. Green procurements prefer eco-friendly, recyclable, and low VOC materials. Standards and regulations. CND Waste Management Rules 2016. It says that mandatory segregation and safe disposal. Lead, Brem, Gree. We have already discussed about that. Lead, Briam, Gree rating system promoting sustainable materials use and recycling. Real life example: Delhi C&D waste recycling plants convert debris into paving blocks, tiles, and recycle aggregates. Demonstrate waste to resource conversion. Efficient waste management reduce material efficient waste management reduce material cost up to 5 to 8%, landfill burdens and environmental impact as well. It reflects professional responsibility, sustainability awareness, and better. It is not optional anymore. It is not optional anymore. It is a core engineering and project management requirements. Okay, let's. I will try. Waste management. What is construction waste management? Construction waste management. Construction waste management is the systematic planning, handling, storage, transportation, and recycling and disposal of materials. The waste generated during constructions, demolitions, and renovations. Constructions and demolitions create up to 30 to 35% of total solid waste in the world. It is also land cover. It's also increase the pressure of landfills. Built environmental contributes up to 38% of CO2 emissions, global CO2 emissions. Waste management influence cost efficiency. Waste management influence cost, environmental impact, and project quality. And C, uh, C&D cost construction and demolitions materials can be recycled up to 70%. Means we can say 70% of the C&D waste material can be recycled. A structural waste materials can reduce up to 5 to 8% of construction project material cost. C&D occupies 40% of landfill space in urban areas. Main source of construction waste is design efficiencies, improper material storage, uh, excessive material storage, site demolition and clearance operations, reworks due to poor workmanships or lack of supervision. We have three types of construction waste: inert waste, non-hazardous waste, hazardous waste. Inert waste like concrete bricks and mortar that can be crushed and recycled on the site. Non-hazardous waste, wood, metal, glass, and plastics that can be segregated, reused, and recycled. Hazardous waste like paint and solvent and adhesive. It can be controlled disposable via licensed facilities. Waste management strategy. You design stage optimization. We should means in the early stage of constructions or plannings, we have to use BIM methods to reduce errors and reworks. A standardized and modular construction to reduce offcut. Ma- just in time delivered to avoid overstone. If you talk about material management, means waste through materials, in which we have material management just in time delivered to avoid overstocking, covered storage areas to prevent in every seasons. On-site segregation, we have to install color coded bins for concrete, steel, wood, plastic, and soils. Segregation prevents contaminations. Segregations segregation prevent s- uh, segregations prevent contaminations, raises recycling and efficiency. Recycling and reuse technology on site. Okay, let's leave. Thanks, gamer bhai. Okay, so what's the things I have to write? Inert waste, concrete, bricks, sand, mortar, none, wood, metals, glass, plastic. Yes, paints, solvents, adhesive, truss and reuse as recycled aggregate, segregate, reuse, mm, controlled disposal via licensed facilities. C&D, paving loop. Okay. Waste management strategy. If you talk about waste management strategy, these first we will talk about design stage optimization. Optimization. Use BIM method to reduce errors and rework. Material management, just in time Alright. हेलो।
जाएगा पोस्टर लगाना।
अभी
हाँ,
जूनियर को लेके जाओ।
जूनियर को जा रहा है, हम लोग वैसे देख रेख के लिए।
ठीक है, अब चलना ही पड़ेगा, अब क्या बोले।
आ जाओ, बाइक से, बाइक है हॉस्टल के बाहर कर दिया तोड़ के।
ठीक है, थोड़ा हम सेशन में थे, रुको, हम तुरंत आ रहे हैं। जस्ट ओके।
आ,
Okay, guys, I am going to our works today, tomorrow. Tomorrow is one event where I have to there. So we are going to do one task. That's poster fixing task. So okay, guys, see you tomorrow. It's a good day. And today I have learned about waste management, and this is the important topic for ABG. I hope you know. So that's is important topics. And again, I will revise this and I will shoot one video for 1 and 2 minutes and definitely upload on YouTube. Thank you. Thank you, guys. See you tomorrow.